My name is Clint from GSI Technical Support. Today's video on loss of flame is intended for all GSI and FFI portable dryers with vision controls. Vision controls utilize a process called flame rectification as the method of flame detection. And today we hope to explain the process and give you ways to troubleshoot and resolve a loss of flame shutdown. This service is moderately difficult and is recommended that any service be performed by a GSI or FFI dealer. Before you begin, please read the relevant GSI user manuals and follow all safety guidelines outlined, including the usage of personal protective equipment and lockout-tagout procedure. To perform this service, you may need the following tools: a 9/16 wrench to remove the side heater panel, 2 wrenches to adjust the flame probe mount, and 2 pair of pliers to adjust the angle on the flame probe. As a reminder, remember to follow the safety guidelines and always practice lockout tagout. If you have questions about lockout tagout, we have a video for that too. Before we begin the actual troubleshooting process, let's take a minute to better understand the process of using flame rectification for flame detection. What is flame rectification? Flame rectification is an electrical process that causes a low-level DC current to be conducted from the flame rod through the flame and back to ground. The current traveling through the flame is detected by a flame control module, which informs the vision control system if flame is present. So, what causes a dryer to shut down with loss of flame error? Because the flame and flame rod are part of the electrical circuit, the physical connection between them must always remain in place. Flame sensing is a physical connection when the flame is in contact with the flame rod. Loss of flame is an open circuit, like turning off a light switch in your home. Now is a good time to point out the common misconception that a red-hot flame rod is sensing flame. A flame probe can be red hot, but still not have physical contact with the flame, so you should not associate flame sensing with a flame probe that is red hot. Remember, flame is sensed by the physical connection between the flame and flame probe. How do you resolve a loss of flame error? Before we get into the more advanced troubleshooting techniques, let's check out the obvious things that can cause a loss of flame error. Check the high temperature wire attached to the top of the flame probe. Ensure this is a tight connection and the wire inside the connector is secure. If there is a break in this wire, you have an open circuit and flame detection is impossible. Next, check over the flame probe mount. Check that the bolt connecting the flame probe mount to the burner is tight. Inspect the area where the mount is bolted to the burner. Look for rust or anything that could cause poor connection. If you find any rust buildup in this area, it is a good idea to remove the mount, clean the entire area, and then replace the mount. Finally, let's look at the flame probe itself. Visually inspect the flame probe. Look for cracks in the porcelain base. Is the flame probe secure in the porcelain? Is the probe clean without buildup? If necessary, use emery cloth to polish the metal probe. Do an overall inspection of the probe and then ensure that it is tight in the flame probe mount. If you are still experiencing loss of flame failure, the next step is to ensure the location of the flame probe in a place where it is constantly in contact with the flame. GSI manufactured dryers with vision controls have a unique feature that informs you when flame is detected. Each burner switch on the vision control panel has a light in the center. The light is used to inform the operator when a flame is detected. Here's how it works. After the fan is running, turn on the burner switch. The burner will go through a 10-second purge delay followed by burner ignition. The length of the ignition time is about 4 seconds. During the 4 seconds of ignition, the red light in the burner switch will turn on. Once the ignition period of 4 seconds ends, the light in the burner switch is used to identify flame detection. If a flame is detected, the light will stay on. The light in the burner switch is the easiest way to tell if the flame probe is physically touching the flame. If at any time the flame does not touch the flame probe, the connection is broken, which results in a loss of flame shutdown. You can monitor the physical connection between the flame and the flame probe with the light on the burner switch. It will go out when that physical connection is broken. Use the burner light as a service tool for when the flame and flame probe are touching. The light should always be on when the burner is in operation. What if the light blinks? What does that mean? Anytime the light goes out, the connection between the flame probe and flame has been broken. When the flame probe is adjusted properly, the light will never blink. Let's review this because it is especially important. If the light blinks, it indicates that the flame has missed the flame probe for just a second. If the connection is reestablished quickly enough, the burner will continue to run. If not, the dryer will go into a loss of flame shutdown. Again, when the flame probe is adjusted properly, the light will always be on when the burner is on and will not blink. Now that you know how to use the burner light as a proof of flame indicator, let's discuss how to adjust the flame probe when you're having problems. Here's an image of a brand new flame probe and a flame probe installed from the factory. Notice that the flame probe is bent during installation, so the rod on the probe is located where it has the best opportunity to be in constant contact with flame. The flame rod is very stiff, and most often used method to adjust it is with 2 pairs of pliers. Here's an example of adjusting the flame rod. Another method is to change the location of the flame rod by turning the mount or totally relocating it. Your goal is to reposition the flame rod so it stays in constant contact with the flame. It is usually accomplished by trial and error. Make a change and then relight the burner. Watch the burner light. If the light blinks or goes out entirely, you should shut down the dryer and reposition the flame probe. It may take a few attempts to reposition the flame rod before you get it in the location that contacts flame all of the time. Now that you have a basic understanding of how flame rectification works, let's look at ways to help guide you as you position the flame probe. The vision control system constantly monitors plenum temperature inside the dryer and the amount of fuel going into the burner to reach and then maintain a constant temperature that is set by the operator. For our example, let's adjust the plenum set point to 120 degrees Fahrenheit. Your set point will likely be very different. When the burner first comes on, the maximum amount of fuel based on your regulator setting enters the burner and the plenum temperature increases towards your set point. This is the best time to watch the light in the burner switch to see if the flame probe is in constant contact with the flame when the burner is on high fire. Continue to monitor the burner light, especially when the actual temperature inside the plenum reaches the 120 degree set point, because when the temperature matches the set point, the fuel pressure to the burner is reduced and the size of the flame is reduced. Now that you have reached the plenum set point and the vision controls have reduced the fuel pressure, you will see most loss of flame failure. The size of the flame has been reduced, so there is less flame in contact with the flame probe. Watching the burner light when the burner is in low flame is especially important. Remember, the light should not blink or go out. A burner will typically cycle a couple times per minute, so don't get in a hurry. Let the burner cycle a few times while continuing to monitor the burner light. That completes this video on loss of flame for dryers with vision controls. The following is valuable information to assist you further. Tips and tricks. Ambient temperature will directly affect burner cycling. For more information on burner cycling, look for GSI videos on burner cycling. Typically, when the flame probe is adjusted correctly, it will not need to be adjusted again. However, there are things that can affect flame detection. Here are a few examples: substantial changes in ambient temperature, incoming fuel pressure. Look for more videos in the future. Thanks for watching.